Okay, let's give you guys some practice. So here you've got a circle of radius 1. You've got a circle of radius 1. Here you've got a circle of radius 2, centered at 2. So somehow work out this area here. So somehow work out this area here. So press pause and have a go. Okay, so to do this, we need to come up with the equation for the blue circle in polar form. Well, the red circle is easy. It's just r equals 1. That will then draw us this circle. But for the blue circle, we need to convert it from Cartesian form into polar form. So so start out with your circle. Start out with your circle, and then if you want a circle of radius 2, put 2 into the r, and then 2 squared will give you 4. So that will then give us a circle of radius 2. Once we've got a circle of radius 2, we will need to shift it across by 2. So to shift it across by 2, we would need to put this into the x here. That will then give us this thing here, and then multiply this thing out. That will then give us this thing here. So to convert it from Cartesian form into polar form, you need to know these three by heart. So try and keep an eye out for x squared plus y squared. Well, here you've got x squared plus y squared. So group them together, and the two 4's here will cancel each other out. You've got a minus 4, minus 4. So that will then take us to here. So here you've got x squared plus y squared. So you can put this r squared into here, and the x here, you can put this into the x. That will then give us this. So whenever you demand that this thing here equals 0, then it will draw out the whole circle, the whole blue circle. But you demanding that this equals 0 is the same as you demanding that this equals 0. Well, you demanding that this thing equals 0 is the same as you demanding r equals 0 or this equals 0. But a circle of radius 0 is meaningless to us. So let's just demand this. Whenever you demand this, you will automatically demand that this thing equals 0. So if you demand that this thing equals 0, then you've got yourself a blue circle. So anyway, the equation for the blue circle is given by this in polar form. So now we've got the two equations in polar form. So to work out the area, remember I'm expecting you to know this. So to work out this whole area here, rather than working out the whole area, let's just integrate it from 0 to the intersection of the two, which is what we're going to work out later. And then later on so to work out this whole area here, let's just concentrate on working out this area here, and then right at the end we can times it by 2, so that will then give us the whole thing. So this whole area here, let's just call it A. It's what we're trying to find out, the whole area. But let's just call this area, half of it, let's just call it B. And then later on we can 2B equals A, the whole thing. So B is equal to you working out the whole area here. You working out, well, you integrating from 0 to wherever this angle will be. Later on we're going to work this out. Whatever this angle will be, theta 1. We're going to call it theta 1 later on. So you integrating from 0, so you integrating this whole thing here. Hang on. So you integrating the whole thing here to what we will later call theta 1. So later on we're going to call this. We're going to work out theta 1 later on. So this whole thing here will then give us this whole thing here. And then take away this thing here. Well, this thing here is really you summing up everything from 0 to theta 1. So it's you summing up all the sectors here. So if you get the whole thing, take away this thing here, that will then give you the area B. But rather than doing that, rather than using this whole thing here, you can just do this. So remember the way integration works in polar form is that well, remember in normal form, if you're trying to work out in normal integration, if you're trying to work out this area here, you can just get the height here. Let's say this is f of x and this is g of x. You can just get f of x, take away g of x, and then integrate the whole thing, dx. So when you get f of x, take away g of x, that will then give you this height in between. That will then give you this height, and you're really summing up all the heights in between. Well, the same thing works in polar form. So what I'm saying here is, instead of you doing this, you can do this. So let me just explain this part here. The way polar form works is that you're summing up all the you're summing up all the sectors. So hang on. So the way integration works in polar form is this. You're summing up this sector here, and then you're summing up this sector here. So hang on. And then you're summing up this sector here, and then you're summing up this sector here. So rather than doing this, you can just get I will continue in the next video.